Hello, this is Anirudh Singh, your Info CS205, presenting the 8th lab experiment in Unix architecture, where we have to define process control and its various applications. So, the first experiment is we have to find the number of hours, minutes, and seconds from a particular input time. So, the program is the program is given over here. So as we can see, inside the main function we define different variables: seconds, minutes, hour, blah blah blah. And printf, we get the parent process by entering get PID. So and then we enter the number of seconds so that it can be calculated into hours and minutes. Then we initialize a process where we create a process int PID is equal to fork system call, which will help us to create a process. Now, if PID is equal to 0, that is the process ID is equal to parent ID is equal to 0, that means this is a child process. So inside we get the details of the child process, that is what is its process number. Example, for we get PID, so we get the child process ID, and if we get PPID, parent process ID, we get the parent process ID. Now inside it we calculate the hours, minutes, second using basic mathematics, and we print out. Now this is all happening in the child process. Now to do for the parent process, the else case is applied, where we have assigned its value as sleep for 2 seconds. That means it will the child process will be completed, and after 2 seconds the parent process will come in place. This is the first program. Yo Kunal. Or the second program is the same thing, but we have to use different variables. We have to create more processes. For example, over here, same thing over here. We define different number of variables. Suppose in this case we have to find the string, and we have to find the string length, the reverse of the string, and palindrome, which all have to be done in different number of processes. So over here, we create a child. We create a this is a parent process. We get the ID, we enter the string, and we get the input of the string, and we store it. We get the string length, and we print the string length. So this is happening in the basis of process. Now after that, we create a child process where if PID is equal to 0, the int PID is equal to fork. This is the child process we created. If PID is equal to 0, this is the child process we enter. We get the ID by printf, a child process and a parent process, get PID, get PPID. Now inside that, we perform an operation for reversing the string, which is basic programming. Then after this, this operation is happening in the child process itself. Now else, after this else case, this comes into the parent process itself, where we again create a child process. PID1 is equal to fork, and then we create another function. We get the value, we get the assigned value to the process ID to the child process, and then we print out whether the string is palindrome or not by comparing each and every string to its character and checking dividing the string between two and checking. And after that else, now this is the parent process of the second function, second process. We check if else leave 5, the parent process will be put to sleep. So this is the second program. The third program is a more amplified version of the previous program, where we have to create different number of processes. We have to create a child process inside a child process, and we have to find different operations, like suppose factorial, Fibonacci, and Armstrong, then prime number, not a prime number, then reverse. It's a basic program. Basically the function of the program is recurring over the previous programs. As we can see, just the level has been modified to a greater extent. Suppose in this the third program over here, the example is given over here, like we define a parent process over here, and we enter the integer. Now we create our own user-defined process, and we inside the child process we create another process. The process B has been created. So then after inside this we find the operation that is factorial of a number. Now again inside this we int PID1 is equal to 4. Again inside this child process we create another child process. So process D is created over here, and we find another function that is Fibonacci series over here. Now else sleep 5, that means the parent process has been sleeping over here. We close both the parent process of the previous corresponding child processes. Now process C is created in the parent function parent process of the A process over here. So since we were dealing with the child process over there, so process C is created, and that is the child process of the parent process of process A. And we find the Armstrong number by performing basic mathematics, finding the power and number of digits and adding it. So inside this process C, we create another child process, that is process C, where we find another operation called prime number. And now we close this child process, and we go to the parent process of the process C created, that is process F. So the process F has been created, and we find the reverse of a number, and we close the process parent process of the F process A. C, sorry. So this is the program. Now we'll move on to the output. So this the parent process has already been predefined over here, and enter the second. Suppose I enter 45 seconds. Like suppose I'll enter a bigger example, like 6,000. So over here, for example, we can see the child process has been defined. The parent ID is also defined, and the values have been converted to seconds, minutes, and hours respectively. Now the output for the second program is so the parent process given. Now enter a string, suppose Sindhi. So this is the length. The string length is 6, and now inside another process, as you can see, the child process and the parent process ID are different. So this is a different, entirely different. The reverse is ID. The reverse program is given, but now these in the above these two cases we can see the parent ID is different. So the child, they are both part of the same process, and the string is not palindrome. The output of the third program is yeah. So the parent process is given with the ID 26484. We enter an integer, suppose 5. So the process B is created, and as we can see, the parent ID is different, child ID is the parent ID is the same, but the child ID is different. And factorial is the program underneath is given. Now as we see, the child ID in process B and process D are same since they are created from the same process, but as we see in process F and process E, they are not. They are the child of the parent. They are the parent process of the child process of process C. So as we can see, different processes have been created in different loops to ultimately convey the same message. So this was this experiment. Thank you for watching this video.